This is the video for Math 95. This is our first topic in factoring, and this is factoring out a greatest common factor. So let's talk a little bit about factoring in general. Factoring is like it is with a number system, it's the opposite of multiplying. So, right, if we do 3 times 5 is 15, right? If we go to factor 15, we split it up into 3 times 5. Okay? And so with algebra, it's the same way. So like if we have a multiplication, 3 times x plus 5 is 3x plus 15. And so factoring will take us back in the other direction. The multiplication takes us in this direction, and the factoring will take us in that direction. Okay? So that's the general idea for factoring. And it's also related to division too, right? Because it's the opposite of multiplication, so it has a lot of similarities to division. So let's take a look at a couple of these problems. The ones at the top of the page start out just getting us used to this process. So in problem 2, we've got 12p to the 5th equals 6p to the 3rd times what? Well, you can fill these in as factors, by saying, oh, what do I multiply the 6 by to get 12? And the answer is 2. And then what do I multiply p to the 3rd by to get p to the 5th? And that's p squared. Now you could also do this by dividing, right? You can take 12p to the 5th and divide it by 6p to the 3rd, and that'll give you 2p squared. Okay, so that's another way to think about it. Let's see here. Problem 4. What do we have? Negative 15k to the 11th equals negative 5k to the 8th. Alright, so what do you need to multiply the negative 5 by to get negative 15? That's a positive 3. And what do you multiply k to the 8th by to get k to the 11th? That's k to the 3rd power. Alright, problem 6. 27a cubed b squared equals 9a squared b times something. So we need to multiply the 9 by 3 to get 27. We've got a squared here and a to the 3rd there, so that means we need a to the 1st power, and same thing with the b. We need a b to the 1st power to get from b to b squared. So now problem 8, so notice that these weren't really the distributive property, okay? So this was just kind of getting us ready to work on the more complex problems. So let's take a look at that. I think problem 8 is the first of those. We've got 18p plus 36. And we're factoring out a common factor of 18. And the question is, what's going to be left after we do that? So what do you multiply the 18 by to get 18p? P. And what do you multiply 18 by to get 36? If you're not sure, again, do 36 divided by 18, and you should get 2. All right, let's keep going here. Number 10. We've got 15x squared minus 30x equals 15x. So that's our common factor. And the question is, what's going to be left inside here? What do we multiply the 15x by to get 15x squared? Well, we'll need an x. And what do we multiply the 15x by to get the minus 30x? That should be minus 2. And you can always test it out by multiplying back through. And again, if you're ever not sure what these end up being, you can take the term and divide it by this thing to get what goes inside the parentheses. All right, let's look at one more. Problem 12, 18 s to the 3rd t squared 2st. So what's going to be left? Let's see. 18 divided by 2 is 9. We've got an s to the third, so we need to multiply this s by s squared. And a t squared, we'll need an extra t there. Then we'll have 5. We've got an st here and an st here, so we don't need any variables. Okay? 5 times 2st will give us the 10st. Okay, so that's the top section of the assignment, and that's to give you practice in how this is going to be working. In the rest of the problems, you need to figure out the common factor for yourself. So let's look at problem 14. We start with 36p to the third plus 24p. Now, I like to handle these problems separately, to look at the coefficients and the variables, and if there's more than one variable, we'll consider them separately as well. Okay, so if we look at the 36 and the 24, now the goal is to factor out the greatest common factor. Okay, so if you recognize the greatest common factor right away, then by all means, go ahead and factor it out. This is sort of like reducing fractions, right? If you've got a fraction like, 70 over 105, I think is a good one. You can see that these are both divisible by 5 because they both end in a 0 or a 5. So we can go ahead and divide by 5. But now there's a factor of 7 that we didn't necessarily see in here originally. And so we can reduce it in 2 steps. Now, if you recognize right away the greatest common factor here, you can go straight from 70 over 105 down to 2/3. But otherwise, you can do it in steps. But just remember to keep reducing until you can't reduce anymore. Same thing here. Okay? So there is a greatest common factor here, but I'm not going to use it right away. I'm going to say, let's see. I know that 4 goes into both of those numbers. So let's factor out a 4. And then the greatest power of p that we can factor out of both of these is just p to the first. This one has a p to the third, but we couldn't factor that out from this one. Okay? All right, so we're going to factor out 4p. That'll leave us with 9p squared plus 6. Now, notice that we still have a common factor inside the parentheses, okay? And in fact, when I grade quizzes and tests and people do that, this is what I do to try to indicate that to them. You've still got a common factor in there between the 9 and the 6. What is that common factor? It's a 3. So now factor out the 3. That'll leave you with 3p squared plus 2. And now multiply that 3 times the 4 that was already out there. And that tells us that the greatest common factor was 12. And if you go back and look at the 24 and the 36, yeah, they both are divisible by 12. And like I said, if you recognize that right away, great. Okay? But if not, you can do that in steps. All right. So let's leave that one up there. And then we'll look at a couple more of these. Look at problem 20. Here we've got 100a to the 5th plus 16a to the 3rd. And let's see. Well, these are both divisible by 4, right? So it's the same thing I was talking about before. Let's look at the coefficients first, or separately. And then we'll look at the variables separately. And it doesn't really matter which one you do first or second. So I'll factor out a 4. I think that is the greatest common factor, but we'll find out. The other thing about doing this in steps is that it's a lot easier to recognize common factors in the smaller the numbers are, right, than it is when the numbers are bigger. Okay, so I'm going to factor out the 4, and then I'll factor out a to the 3rd, right? So that'll leave us with 25 here. this will be a squared, and then plus 4, and we factored out that a to the third, so that's it. Now, do the 25 and the 4 share any common factors? No. So this is done. This is the greatest common factor, and this has been completely factored. Okay. Now we'll see a couple more that are a little bit more complex. Problem 22. So let's see, we start with 30. X cubed yz squared minus 24 x squared y cubed z. All right. So again, what's the greatest common factor? You can see that they're both divisible by 2. Go ahead and factor a 2 out. I'm going to use a 6. I see that they're both divisible by 6, so I'm going to factor that out. Okay. What about the x's? Well, we've got x squared here and x cubed here, so that means we can factor out x squared. Here we can factor out a y, because this one has a y to the third, and we can factor out a z as well. Okay, now the question is what's left. What do you multiply the 6 by to get 30? 5. Let's see, we've got a x to the first left, the y got factored out, and a z to the first. And then 6 times 4 is 24. X squared got factored out. One of the y's got factored out. That leaves us with y squared, and the z got factored out as well. So there it is. There are no more common factors inside here, right? Not in the coefficients, not in the variables. So this is completely factored. And notice how I treated these separately. I did the coefficients, then I did each variable separately. And that, I just find that it's a lot helpful to kind of break it down that way. Makes it a little bit less confusing. All right. Let's see here. Well, let's do problem 26. What do we have? 4 ax to the third y to the third minus 6a x squared y squared plus 4a xy squared. All right. Well, the coefficients are pretty simple. This one, right, we've got common factors of 2. Then, let's see, they all have an a to the first. This is x to the first, so that's all we can factor out. But they've all got at least a y squared, so we can factor that out as well. Now what's left? Here we'll be left with a 2. And let's see, we took the a out, we took one of the x's, so we'll be left with x squared, and we took a y squared out, so that leaves us with just y to the first. Here we'll have a 3. The a gets factored out, we'll have an x to the first left over, and the y squared got factored out. And then here we'll have a 2 again. The a gets factored out, the x gets factored out, the y squared gets factored out, and there we go. Okay? The coefficients don't share any common factors. These two have an x, but this one doesn't. This has a y, these two don't. So what I'm saying is that this can't be factored anymore. There's no more common factors inside here, so we're done with that. All right, let's see here. Oh, let's go ahead and do 28. 28 is probably the most complicated one of these. The numbers are pretty big, plus there's 3 different variables to work with. Okay, so in 28, we start with 21 t to the 4th u to the 3rd minus 105 t to the 5th u to the 3rd v plus 63 t to the 6th u squared v v to the fourth. All right. So let's see here. Well, in looking at these numbers, they're not even numbers, so we can't factor out a 2. What else? Well, so now it's up to you. You know, you've got to try numbers out. 2 and 3 and 5 are good numbers to try when you're looking for common factors because they're simple. And don't be afraid to use your calculator. Divide these numbers, like if you want to know if 3 is going to divide into one of these numbers, try it out. Do 105 divided by 3 and see what you get. Okay? So let's test it out. Let's do that. So you do 105 divided by 3, and that gives you 35. Okay, so we know that this is divisible by 3. This one, if you don't know, try it out too. Do 21 divided by 3. But this is 7 times 3 right here. And the same thing with 63. You can divide that by 3, and that should give you 21. So at least we know we can factor out a 3. Okay, so let's do that. That may not be the biggest common factor, but once we factor it out, it might be easier to see other common factors that are left. Okay? All right, now what? The t's, we've got t to the fourth. Well, let's do that. There we go. T to the fourth, t to the fifth, and t to the sixth. So the biggest one that we can factor out is the t to the fourth. And then we've got u to the third, u squared. So we can factor out that u squared. Now these two have a v, but this one doesn't. So that's not a common factor. We're not going to be able to do it. We're not going to be able to factor it out because this one doesn't have any v's. All right, now what's left? We factored out the 3. That means we're left with 7. T to the fourth got factored out. We factored out u squared, so that leaves us a u to the first. Let's see. Oh, we did 105 divided by 3. That turned out to be 35. Factored out t to the fourth. That leaves us with t to the first. And same thing with the u's. That leaves us with u to the first. And this v didn't get factored out. Okay, so it stays where it is. Now we factor out a 3 from here. Leaves us with 21. T squared. The u squared got factored out. And then we've got the v to the fourth. So now look at what's left in the parentheses. Okay? We can't factor out any more of these variables, right? These two have a u, but this one doesn't. These two have a t, but this one doesn't. These two have a v, but this one doesn't. All right, so there's no common factor in the variables, but notice in the coefficients, we do have a common factor of 7. And like I keep saying, if you recognize that right away, great, go ahead and factor it out. But if not, factor something out, and it may be easier to see another common factor. So let's take that out. So that'll just be 1u, that'll be 5tuv, and that'll be 3t squared v to the fourth. And then the last thing we want to do is multiply these. So as it turns out, our greatest common factor was 21, t to the fourth u squared, and then we're left with this inside the parentheses. Okay, so like I said, that's probably the trickiest one of the greatest common factor problems. So now let's look at the end of the worksheet there, which is a different kind of factoring called factoring by grouping. And it's related to the greatest common factor method, okay? But it's a little less common and it's a little bit trickier to work with. But let's give it a try here. So one hint that you've got a problem that lends itself to factoring by grouping is we've got 4 terms here. All right. So there's our 4 terms. And the trick to doing this is to split it down the middle. Sometimes you might have to rearrange these to do that. But in this case, we don't. Okay. Now, forget about this for a minute. Look at these 2. Factor out a common factor. In this case, just m to the first. And that'll leave us with m plus 2. All right. Now, forget about all this. Only look at these two. Factor out a common factor over here. Here, we've got a common factor of n. And what does that leave us with? M plus 2. All right. Here's where it gets a little bit tricky, but it's really not that bad, okay? Look at this m plus 2. Now, imagine that we had like m times a plus n times a. All right? Forget about all this for a minute. We'll come back to it. But just what if we had this problem right here and we wanted to factor out a common factor? Well, I wrote the a in red because that's the common factor. And that would be a times m plus n. Relatively straightforward. And this is the connection between factoring by grouping and factoring out a greatest common factor, is that this thing right here is a. It's a common factor. It's in both of them. Just because it's in two pieces doesn't change that. So we can factor this out just like we factor out the a. And that'll leave us with m plus 2 times m plus n. And if you multiply this back together, you should get the original statement. Okay? So that's how this factoring by grouping works. Let's look at a couple more examples here. Problem 32. We start with y squared minus 6y plus yw minus 6w. All right. So the first step is pretty much always split this in two pieces. Like I said, sometimes you might have to rearrange them. I don't think I put any of those on here. Okay, now look for the common factor. Pretty straightforward. In this case, it's y. Same thing here. What's the common factor for these two? W. And notice that when we do that, we get the same thing in both parentheses. And if you don't, you can't take that next step. If you don't have the same thing here, it's not a common factor. Okay? So these have to match. And then we factor it out as a common factor, and we're left with y plus w. All right, let's keep going. There's one tricky part to this that we haven't gotten to yet, and we will get to a couple of those. Yeah, problems 38 and 40 are like that. Let's do one more before we get to that. All right, let's see here. Which one do we want to do? Let's do 34. Okay. 5m squared plus 15mn minus 2mq minus 6nq. Okay. This does have that tricky issue in it. So again, first thing, let's split this in two pieces. All right. Over here, common factor of 5, and they both have an m. So let's factor those out. And that leaves us with m plus 3n. Now, this is what's tricky. Notice over here you've got a plus, and then we end up with a plus down here. When you see a minus here, that indicates that you're probably going to need to factor out a negative. All right, that's what makes it a little bit tricky. So, negative what? Well, we've got a common factor of 2 and q. All right? Now that we factor that out, we're left with a positive m here and a positive 3n, right? If we multiply back through, there's minus 2mq and minus 6nq. And again, not only that, these have to match if we're going to factor it out as a common factor. So m plus 3n, and then 5m minus 2q. Okay. So that's the tricky part. Now 36 goes back and has a plus sign there. So let's take a look at that one. And that is 8y squared minus 4y plus 6y minus 3. And again, the key to making that decision is when you split this in half here, if there's a minus sign, then you'll probably have a minus sign and a minus sign like that. If there's a plus sign, then it'll be plus in those places. Okay, so what's our common factor here is 4 and y. What's left here? 2y. And don't forget, you're going to have a minus 1 there. All right? Now, plus, because that's a plus. Common factor here is just 3. And again, that'll leave us 2y minus 1. That's our common factor. And that'll be multiplied by 4y plus 3. Okay, let's look at one more. Let's see here. Problem 38. This is a pretty standard problem. This is something you see frequently in textbooks and on quizzes and tests. So you've got x cubed plus 3x squared minus 2x minus 6. All right, so again, split it in two pieces. And notice this is a minus, so that's probably going to tell us that we're going to be looking to factor out a negative there instead of a positive. Okay? All right, let's do the front part first. Our common factor here is x squared. And that'll leave us with x plus 3. Here, our common factor is going to be minus 2. And that'll leave us with an x. And this is something people often forget, plus 3, right? Because when you multiply negative 2 times positive 3, you get negative 6. All right, now that we've got that set up, factor out the x plus 3, and we'll be left with x squared minus 2. Okay, so that's it for the first factoring assignment. We'll continue making our way through this topic of factoring, and that'll take us into next week. As always, if you have any questions, please call me or email. And I'm starting those Zoom meetings next week as well. So we'll have that opportunity. And also the math lab. I'll be doing a Zoom math lab from 12 to 2 on Tuesday through Fridays. So if you have any questions, please let me know.